Today we're going to look at what an electrical current is. With electricity, we would use a model to describe exactly what it is, because I'll be honest, I'm not sure anyone can explain properly what we mean by electricity. So to start with, we've got this orange dot, and that's going to represent an electron. That electron gets pushed by the cell or battery around the circuit, and we can describe it moving just like water flowing through a mill. But rather than water particles flowing through a pipe or through a mill, we would call them electrons, and they move around the circuit. An electron is a type of charge, and just like when we use the word charge to charge our phone, what we're doing is we're putting electrons into our phone, which then enables it to work as normal. There are three options when talking about charge. We can talk about protons, they have a positive charge. We can talk about neutrons, which have a neutral or a zero charge, but in this case and the whole of the electrical topic, we're talking about electrons, and they have a negative charge. So we can talk about electrons moving around the circuit, or we can talk about charge moving around the circuit. Electrons are a type of charge. When we talk about a current or a water current, we talk about how quickly water flows through a pipe or through a water mill. With electrical current, what we're talking about are how quickly these electrons are going round the circuit. Or we can say how quickly the charges are moving around the circuit. And rather than saying how quickly, we would use the word rate of flow. So how quickly the charge moves. So our definition for electrical current is rate of flow of charge. And as ever, that then leads us to an equation. So current equals charge divided by time, how quickly charge moves. Shorthand, weirdly, we use I for current, charge, shorthand is Q, and the symbol for time, as ever, is little t. More useful perhaps are knowing the units, so current is measured in amperes, or capital A. Charge is coulombs, capital C, and time is measured in seconds with a small s. So let's look at an example question where we're going to need to use this equation. So in an appliance in a circuit, there is a total charge of 5 coulombs that flows. The current is 10 amps. Calculate the time the appliance has been on for. So, as ever, we need a strategy. Let's look at one of those first. So, we need to bug. So we need to box the command word, underline key information, look out to check if we need to convert units, so milli or kilo, and then we need to go. But before we can carry on to get to the answer, we need to then choose the right equation. In this case, Q equals IT. We then need to substitute our values in, so for each one we'll write the equation and put the numbers underneath it. And then calculate the answer using a calculator. You can use a calculator in physics, but we might need to rearrange the equation. And the final part is to always remember the units. As I've said, charge, capital C for coulombs, current, capital A for amperes or amps, and time in seconds with a small s. So we start by bugging. So box what we need to do, so calculate the time, and then underline, or in this case I've highlighted, so charge is 5 and current is 10 amps. In this case we don't need to convert any units because it's in coulombs, there's no kilo, there's no milli, and same for our amps. I'm going to write down all the things I know down the side, so Q, I and T. So Q is 5 coulombs, current is 10 amps, and our time, well, we don't know, so I'm just going to put a question mark. So now we need to find the right equation, of which, as you've guessed, Q equals I times T, charge equals current multiplied by time. I'm going to substitute the values in underneath, so where I've got Q, I'm going to write the 5 underneath. Where I've got the current, I'm going to write 10 underneath, and I'm going to leave time as it is because that's the one we're trying to find out. I now need to calculate the answer, but I do need to rearrange it in this case. So 5 equals 10t, so I need to get time by itself. So I'm going to divide through by 10. So 5 divided by 10, and that then gives us our time. Now you might be able to do this one in your head, but don't forget, please do tend to use a calculator. And the final part is to remember the unit, and time is measured in seconds. So our final answer, time equals half a second. So I hope you found that useful, and please do remember to subscribe for any future videos that get made.